Hi. So today we're going to talk about scale drawings, and I want to remind you what we have been talking about leading up to this. As I do every day, I want to review what we started this unit with, which is a ratio. A ratio is a comparison of two numbers. So we're comparing A and B. Okay. A more specific ratio we called a rate. And a rate is a ratio. It compares two numbers, but those numbers have some sort of measurement. So A uh, gallons to B miles. We are now measuring. So it is a more specific form of a ratio. Even more specific than a rate is a unit rate. Unit rate is a comparison of two numbers, but is specific a comparison to one. So when you divide, you get some number over one. So how many gallons per 1 mile? How much money for one notebook? How many books per person? All of those things are measurements. And then we moved into, all right, well, if you have two rates or two unit rates that are equal, then they are in proportion, or they are proportional. So we have something like A over B equals X over Y, two ratios that are equal. Okay, now, why do we need this stuff? We talked about unit rate, being able to um, compare things so that they're out of the same amount, and then deciding on the better deal or the shorter distance or any of those type of things, making decisions in our life. Another way that we use them is proportional as far as scale drawings. You see drawings that are small, like maybe you put a picture of your bedroom on a piece of paper and move your furniture around to see if your bed will fit going a different way and not block the door. But you don't physically move your bed around, because what if it does block the door? Or maybe you do and you just cause a lot of stress for your parents. But at any rate, we scale things down to fit on one page so that we can see what's happening before we actually do it. So here's an example. It depends on what you're viewing this, but this is not the size of my cell phone. Okay. If you're viewing this on a Chromebook, this is probably much smaller than your cell phone. I'm viewing it on the smartboard up front, and I'm holding my cell phone next to it, and it's actually much larger than my cell phone. So sometimes we make things bigger or smaller so that we can see them better. So if I made this a little bit bigger, I might be able to say, oh, I want you to look at this app. And I can really zoom in on that app and show you some things and teach you some things, but this is not the size of the cell phone. So we want to look at things in proportion, scale them so they're all the same. Here is a scale model of the skeletal system. This clearly looks like a skeleton, but it's in proportion. You can still see that that the head is smaller than the body, that the the leg bone down here is longer than a finger. Okay, so everything is in proportion and labeled so that if you were to look at this on a human, a real human, you'd know that the clavicle is here and is shorter than the humerus. All right, so it's in proportion. You don't want to draw a scale model and have like like short arms and long legs. Won't make sense. Someone who goes to medical school won't know what a real person looks like. Now, here's a little Lego Einstein. Lego Einstein is just little. He literally fits in the palm of your hand. The real Einstein was my size, okay? But in this small one, you can see that his arms are in proportion to his legs, his feet. You can see it's a human, right? His head is smaller than his shoulders. This thing kind of looks a little big. I don't know what he's carrying there, but you can tell who he is and what it is because everything is sized the same up or the same down. Here's an example of something opposite. We take something really, really small and blow it up so that you can see it. You cannot see a cell with your eye, but we do use high-powered microscopes so that we can see what's in them. And then this picture just blows it up so we can see all the different parts and pieces of the cell. All right, so now that we know why we might use a scale drawing, let's talk about how to do that. So I hate filling in other people's blanks. A scale drawing or a model is used to represent an object that is way too big or way too small to be shown in its actual size. So for example, we wouldn't show the whole world. We use a globe because the world is way too big. But in the example of the cell is way too small, so we had to blow it up so we could see it. The dimensions of the object on the scale drawing or model are proportional. The scale is the blank of the size of the model. Oh, it's the ratio. There we go. Using a very fancy math word. It's the ratio of the size of the model to its actual size. Model to actual. So the scale is the model size to the actual size. The model is a small one like the globe. Okay. All right. So let's take a look at how we use this in our world. We're going to set up and solve a proportion. You know me, I like to use cubs. This is a word problem, so I like to break it down into what I already know. James is building a dollhouse that is proportional to his own house. So you know the dollhouse is going to be smaller than his actual house. He's using a scale of 0.5 inch equal to 1 foot. If the dollhouse is 12.3 inches tall, how tall is his house? When we were doing proportions yesterday, or Friday, whatever day it was, last time, we used a little, something's coming in here. We used a table to help us. So I'm going to do the dollhouse. Yeah, I'll put it here. Dollhouse to the actual house. Right? The dollhouse is smaller. So 0.5 inch of the dollhouse was 1 foot in the real house. Now we go to label the 12.3 inches. If the dollhouse is 12.3 inches, notice my labels here. So where do I put that 12.3? I'm going to put that in the dollhouse. That's the 12.3 inches. All those labels help us to decide where our numbers go. How tall is his house? This is what we're looking for. How tall is his house? So you can clearly see now what you're putting your proportions. 0.5 over 1 equals 12.3 over x. And you guys know how to solve that. You're going to cross multiply right here, whichever method you use, the butterfly or the shoelace, equals 12.3 There's your split and your inverse. Divide both sides by 0.5. Ooh, I put my calculator away already. I have to get a real calculator. 12.3 divided by 0.5 is 24.6. So what is that 24.6? How tall is this house? It's going to go here. It's feet. So his house is 24.6 feet tall. I really like using this table here to help us organize our information and know what to do with it. Okay, here's one that has to do with a highway. The length of a highway is 1,500 miles, 1,500 miles. If 2 inches on the map represents 250 miles, what is the length of the highway? I could write a let statement right there. Let x equal length of the highway. And I want to organize my information. So I'm going to make a table. And think about what 2 things you are comparing. All right, the length of the highway. So we're comparing inches to miles. I'm just going to put that right in here. Inches is being compared to miles. Go back and read. Well, here's 15. The length of the highway is 1,500 miles. So under miles, I'm going to write highway. And I'm going to put 1,500 right here. Okay. Keep reading. If 2 inches on the map represents 250 miles, so inches is my map. Now, do I put that 2 inches here? Does that go with 1,500? It doesn't. It goes with 250. So I'm going to put my 2 inches here and my 250 miles down below. That means this box is my x. And there you have your 2 ratios. X over 1,500 equals 2 over 250. You can go ahead and cross multiply. I always like to do my x first. So I'm going to have 250x equals, this is 3,000 when I multiply this way. Split, inverse. This is old news. This is something you already know how to do. Type that in. 12 comes out nice and even. X equals 12. And what is that 12? Go back to where your X is right here. 12 is your inches on the map. So the question is, what is the length of the highway on the map? Phew, I had to read that. The highway is 12 inches on the map. It's much, much further in real life, but you can't show that on a map. So that's how we do that. Okay. Remember, you can always freeze this if we're going too fast, or back it up and watch it again if it doesn't make any sense. All right. So I'm going to skip the next one and go to the one that says a floor plan of a home is shown where 1/2 inch represents 3 feet of the actual home. What is the actual area of the bedroom? Okay, so in order to find area, we need to know a couple things. What is the area of a rectangle? How do we find the area of a rectangle? Hopefully, you guys remember from elementary school, area of a rectangle is length times width. My length is more than my width. Okay, so area of a rectangle is length times width. You may also sometimes say base times height. They are the same thing. Base and height meet at a right angle, so that's why you can use those also. Okay, all right, so we can't just go straight to the area. we have to find the width of the bedroom and the length of the bedroom. So come on over here to the picture. Here's the whole house. We don't want the whole house, do we? No, we just want the bedroom. So in the picture, the length of the bedroom is 5 inches. This is the length, and the width is 2. All right, this ratio here kind of reminds me of that table we were using, right? So that's my label, my scale drawing. The length is 5 inches. So I'm going to put that in the top here, 5 inches. And we don't know the actual length, do we? The information we do know is given in the question, where 1/2 an inch is equal to 3 feet. So I'm using my table to help me decide what goes where, and it helps me set up my proportion. So 5 is to x as 1/2 is to 3. Is it okay for me to have a fraction inside of my fraction? That is, we talked about those complex fractions. So now we're going to cross multiply. 1/2 x equals 15. I want to get x alone, so I'm going to divide both sides by 1/2. X equals 15 divided by 1/2 is 30. So this is 5 inches on your piece of paper, but it's 30 feet in real life. Still can't figure my area yet. I need to get some carpet, but I need to find the width now. Oops, I did these backwards. This is length. Now I'm going to do width down here. Sorry. Same thing though, except this time I have 2 inches. I'm going to just make this into my table. All right. I know this same information applies. So I'm going to put 1/2 inch for 3 feet. And 2 inches is my width on the drawing for x feet. And this shows me my 2 ratios. 1/2 is to 3 as 2 is to x. I'm going to cross multiply. 1/2 x equals 6. Split and inverse, divide both sides by 1/2. X equals 12 feet. So this width is 12 feet. This is actually a pretty big bedroom. 30 feet is huge. Now that I have those 2 measurements, I can find the area. Area equals length times width. This is 30 feet times 12 feet, which is 360 squarea the area. So this is square feet. Whew, that was an awful lot of work, wasn't it? It was. You cannot just take this right here and find area, because if you did 5 inches times 2 inches, you would have 10 square inches. Is this scale square inches to feet? It's not. It's only inches to feet. And that's why you have to go through each side and then multiply. You can't just skip a lot of steps and go straight to finding area. So that is a lot. Remember that you can go back and watch again anything you didn't catch, but that should lead you to your lesson 6 homework. Ooh, how do I stop this crazy thing? All right, see ya.